Hello and welcome to the Data Engineering Podcast, the show about modern data management. Have you ever woken up to a crisis because a number on a dashboard is broken and no one knows why, or sent out frustrating Slack messages trying to find the right dataset, or tried to understand what a column name means? Our friends at Atlan started out as a data team themselves and faced all this collaboration chaos. They started building Atlan as an internal tool for themselves. Atlan is a collaborative workspace for data-driven teams, like GitHub for engineering or Figma for design teams. By acting as a virtual hub for data assets ranging from tables and dashboards to SQL snippets and code, Atlan enables teams to create a single source of truth for all of their data assets, and collaborate across the modern data stack through deep integrations with tools like Snowflake, Slack, Looker, and more. Go to dataengineeringpodcast.com/Atlan today, that's ATLAN, and sign up for a free trial. If you're a Data Engineering Podcast listener, you get credits worth $3,000 on an annual subscription. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's LINODE, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Your host is Tobias Macey, and today I'm interviewing Ben Bromhead about the recent release of Cassandra in its version 4 and how it fits in the current landscape of data tools. So Ben, can you start by introducing yourself?
Thanks, Tobias. Yeah, my name's Ben Bromhead. I am the co-founder and CTO of Instaclustr. Instaclustr, we essentially do managed Apache Cassandra as a service across all the major cloud providers, plus some other really cool data technologies like Kafka and Redis and Elasticsearch. We've been in the Cassandra community for quite some time now, kind of going on 8 or 9 years. So yeah, super excited to talk about what's happening in Apache Cassandra today.
And do you remember how you first got involved in data management?
Yes, I do actually. A bit of a convoluted path. My career in technology actually started off in IT security. So I was working at an IT security consulting company on the assurance side and the penetration testing side of things. On the assurance side of things, we spent a lot of time working with different technologies used in large organizations, and particularly government, used for doing things like, protecting internet gateways and websites and other things and providing assurance around the way that they're built and configured. And quite often they ended up having, different backing data stores. So got a lot of experience working with things like, Oracle and MySQL to set up public key infrastructure products, but started to notice a bit of a turn when we started to see this next generation of gateway monitoring tools and capabilities coming out and different projects and different experimentation and a lot of activity in the open source space where, you'd be choosing these backing data stores, and worked with a company who started leveraging an intelligence product based on Apache Cassandra. And that's kind of the first time I heard about it. But it wasn't until a little bit later on when kind of got sick of breaking things on the security side of things and I wanted to go build things that, one of the things that we started building was essentially a data marketplace. I think a lot of engineers have gone out and tried to build something like that. And, we gave it a go too. And one of the requirements we found that we had was the ability to kind of store and replicate data across different, regions and geographies. And Apache Cassandra was an awesome fit for that, right? So that was the first time I actually used it in Angra and, got a chance to play with it. Unfortunately, at that time, there's a lot of work you had to do to get it set up, right? It's a lot different from managing just a single MySQL database, right? So we spent a lot of time on, the tooling and capability to go and deploy this, to go and run this. And for a startup, that's just an absolute, time sink, right? You want to be working on whatever it is you're doing, right? Not fighting your database. But we fought the database and we finally got there. And at one point we decided, hey, maybe some other people would be interested in some of the stuff that we've done. So we kind of threw together a bit of a web interface, some credit card billing. We turned it into a managed service. 3 months later, we had 10 people in production. And we're like, we should do a good job of this. And that was kind of how Instaclustr got started. But that was really my first experience with Apache Cassandra, was using it to solve this particular itch, and then realizing actually, hey, it's a really good fit for other people, and seeing how other people had challenges in running it and making it easier to access Apache Cassandra.
It's funny the number of times I've had a conversation with somebody of, oh, how did you get involved in this? And, oh, I was actually trying to solve a completely different problem, which I still didn't actually get to. But on the way, I found this other thing that's really fun.
It's so true. And I mean, when I recount that story, it seems very clear. But, I'll definitely say there was like a good year where we were kind of working on both things at the same time and wasn't too sure which one, would kind of take off or go in one direction. But, with Instaclustr and providing that Apache Cassandra capability, like people just kind of kept on coming and it just kind of kept adding to it. And, we got a year in and we're like, hey, this is it. We've got to go. And, Instaclustr's, off the back of that, we've now jumped to, I think, like 200 employees or something. So it kind of feels like this little thing that just got out of hand by us trying to, make it a bit easier to use a database. So here we are.
And so for anybody who isn't already familiar with the Cassandra product and some of the capabilities that it brings and some of the use cases that it's aimed at, can you give a bit of an overview about what the project is and some of the story behind how it came to be and its sort of overall role in the open source data ecosystem?
Yeah, sure. So the high-level description, so Apache Cassandra, it's a open source and OSQL distributed database, right? It's got some really cool architectural things that came out of the back of its origin that make it really, really useful. It was actually originally built or created at Facebook. They built it for inbox message, which I believe it was, kind of a bit of a very specific use case they had in mind. And it got used there for some period of time, not a whole lot, but eventually it got open sourced. I want to say in 2008, roughly, it got open sourced and got released. And then about a year later, it eventually made it as a donation into the Apache project. Interestingly, Facebook didn't use it for that long. They ended up, I believe, moving some of that functionality into HBase, actually. But through the process of open sourcing it and releasing it into the community, a huge ton of other companies were actually like, oh, hang on, this solves our particular use case. And interestingly enough, not so much around message searching, but a whole bunch of other use cases, like really, really great for kind of time series data at the time, really, really great for write-heavy workloads at the time, really, really great for pretty much most of those, I guess, use cases where companies had reached the limits of how you could scale with a traditional database or even a traditional clustered or, manually sharded database, right? And so that's where you started to see it getting picked up, by companies like, Netflix and Rackspace, Apple and Intuit and a whole bunch of other really, really big companies kind of grabbing this database and using it to replace some of those transactional use cases, right? And the reason why I think a lot of these companies gravitated towards Cassandra is a few reasons. First of all, it treats, awareness of different locales or different regions or different failure domains is what I like to use in this case. It treats them as a first-class citizen and understands data placement in regards to those fault domains, right? So what you can do with this Cassandra is you can say, hey, Cassandra, I want you to replicate, this particular table, this particular key space, whatever it is, 3 times. I need at least 3 copies of this in this data center. I need at least 5 copies in this data center, or however you want to do it. And there's a whole bunch of, math that kind of indicates, like, based on what consistency and stuff you want with your data, what replication factor you should have. I won't get into that at the moment, but suffice to say is that control and that treating, ideas like where your data lives, consistency as first-class citizens, where the developer has to think about it up front when they perform a query, is really, really powerful because it actually means that the developer is then building applications that are naturally resilient, right? And that brings us to the really, really core point, which is Cassandra lets you actually survive outages. It lets you have a node go down during the middle of the night and you don't have to necessarily get up and fix it. It lets whole data centers go down, right? And, as long as the rest of your application fails over in the right way, you're going to keep on chugging along, right? So that resilience is really, really important with Cassandra, right? That's one of the core reasons. The second core reason is linear scalability, right? So with Apache Cassandra, if you want to scale up the performance side of things, right, it's just a matter of adding more nodes, right? And because it takes what's called a masterless architecture, and it got that from the Dynamo white paper. So, one of the original engineers who worked on this was actually an Amazon engineer, right, and worked on the original Dynamo system, right? So it took a lot of those concepts and applied it to Apache Cassandra. So what you can do with that is if you want to double your performance, you just double the number of nodes or servers that are participating within the Cassandra cluster. There's a few reasons why that makes it really, really simple. Again, that's a whole nother hour of explaining and getting into it. But, those are kind of, I think, the really two core powerful things why people started to really gravitate towards Apache Cassandra, right? Is, the high availability and then the high scalability.
And you mentioned that the way you got involved in the overall project and community was by trying to build out this project of being able to do this sort of data marketplace, and ended up accidentally building a whole successful business around it. And so I'm wondering if you can just give a bit of an overview of your perspective on your role within the community and some of the ways that you're engaging with the project, both in terms of the business side and from your sort of personal engagement with the project.
So I guess certainly on the business side, we spend a lot of time in the community. We have committers who work on the code base. Even our engineers that are not committers spend a lot of time working on, bugs and fixes and features and other bits and pieces. And we like to kind of contribute back there. I think, one of our philosophies, so we work in a number of different open source communities. It's not just Apache Cassandra, it's Postgres, it's, Apache Kafka and that kind of thing, is, we don't aim to, what I would say, dominate a particular community or kind of, own that particular space. But, we're very aware of making sure we contribute back, our fair share and try and do that. And it's not just around code contributions, right? We spend a lot of time as well, talking at conferences, talking to wonderful podcasters as yourself, running meetups, doing training, doing all that kind of thing. That there's really important parts of the ecosystem as well, and part of that community, and getting the good word out there and helping people be successful at that as well. So that's very much on the Instaclustr side of things. Personally, I don't get as much of a chance to contribute back to Apache Cassandra as I used to, or as I like to. One of the joys of running a business. But, when I do get the chance, staying involved with how the community presents itself, how they talk about this, about the project, kind of contributing, and, also making sure that Instaclustr resources are deployed within the community in the way that the community kind of works as well, right? So that's kind of more of the role that I find myself in on a day-to-day basis. I have submitted a few patches, but I think I could count them on one or two hands, to be honest. That's the joy of being a CTO, is that ostensibly it's a technical role. It's really not.
And so that brings us to the most notable piece of news coming out of the Cassandra project recently is the major release of version 4. And when I was looking through and preparing for the show, I noticed that the prior release of version 3 was all the way back in 2015. So it's gone 6 years between major releases. And I'm wondering if you can give a bit of an overview about what is notable about the version 4 release, both in terms of the technical aspects and some of the aspects of why it went so long between releases, whether that's because there wasn't really a major need of it or just the overall sort of engagement or complexity of being able to be confident in that. And I know that one of the aspects of it is that it's a database, so it's a very core piece of everyone's infrastructure. So you need to make sure that it is 100% reliable and is not going to break or lose data.
Yeah, no, so true. So the 3.x branch, as we call it in the community, it was kind of a bit of an interesting experiment where we approached it from, and it was called a TikTok release cycle, right? So it would kind of be, evens would be new features, odds would be stabilizing, right? And with a goal of kind of doing a release, I think it was every month. It's 5 years ago, I can't remember. What was interesting with that particular experiment is I think it did bring kind of the velocity that previously the Cassandra community had been a little bit concerned about. The problem, of course, is that quality, I think, kind of suffered. And so, it was some time before people kind of got confident. I think 3.7 was kind of when, people will start kind of like game enough to start to deploy some of this capability into production. And then, of course, you start adding new features on top of that again. And then it was again about 3.11 that it really started to stabilize. And even then, we're still up to like a significant minor patch number with that. So That was kind of the TikTok, and it's named after the Intel release process, not the video-based social media site. So that was kind of the experiment, right? And we kind of got to 3.11, and I think that kind of just ran out of puff a little bit, and there wasn't a huge appetite to continue that, right? So it was kind of, that was pulled, and then we're like, hey, let's work on 4.0. And so the community had a bit of a discussion around what is important as part of 4.0, right? And the thing that came up was stability, right? So the fact that Cassandra community traditionally had a great reputation around releasing a .0 release that you can use in production. And so, a lot of the big contributors to the project kind of all came together and said, hey, look, we'll only release 4.0 when we can all say, hey, we've ran this in production ourselves, right? So we just move the bar from here to way up here all of a sudden, right? And, some of those contributors were still on like the 2.0 branch as well, because they weren't convinced about the stability of the 3.x branch, right? So there was a lot of that kind of going on. In the meantime, I think there was a number of the other commercial players in the community. Some of their priorities changed a little bit. One of these contributors hired a lot of, or employed a lot of committers. So people that, had permissions to commit patches and do all that kind of stuff. And also, I think a lot of the know-how in the community around certain subsystems, they had a bit of a change of priorities, which meant that not as much of those committers had, I guess, employee or paid time to go work on the project. And so I think losing what I'd call that the middle bar of experienced committers also set that release cadence back a little bit, right? Having said that, that contributor over the last few years has kind of had a bit of a change of heart and done a bit of a 180 on that previous, I guess, perspective. And, we're starting to see, more of those folk being able to spend more time on the project, which is really, really awesome to see them kind of coming back into the community. We're kind of super excited to welcome them back in that sense, which has been really, really good. So having, I think that kind of, confluence of factors kind of caused that, what I'd call, 5 years of trying to get this out the door. But, certainly I think the quality gate was a lot higher. The requirements on testing were a lot higher. We've gone from a project that I think has never had a green run on its CI system due to flaky tests and other bits and pieces. So everything now passes beautifully and reliably. So there's been a huge investment from the community on kind of getting that. And I think the stability of 4.0, really shows that. I mean, look, it's software. There's still bugs, right? But, there hasn't been anything quite as debilitating or show-stopping as kind of what we've seen in the past. So, super proud of the community for kind of the work that they've done on how hard they've worked on it and the perseverance as well, right? 5 years is a long time to kind of maintain that confidence, right? It is a long time. And, you watch users going, hey, when's the next cool version coming out? When's this new feature kind of coming out? So I think, keeping up that confidence, keeping everyone patient with the process has been a bit of a task as well. But we got there, and I think we're all pretty excited about seeing how people use it. We're pretty excited about 4.1, and I think we're going to get into a bit of a better cadence, and it's going to be a little bit easier to release some of this stuff now that we've kind of cleared a lot of those quality gates. So yeah, super excited to see the progress as we go forward with this.
As the saying goes, the only software without bugs is the kind that nobody uses.
Well, that's it, right?
To the point of the sort of quality gates and the building of confidence in the release cycles and maintaining stability, I'm wondering if you can talk to some of the supporting tooling and some of the overall development approach and architectural aspects of being able to build in that stability, build in that level of confidence, and be able to say at that 4.0 point that, yes, this is ready to go. You can put this in production. I will stake my reputation on it.
In terms of some of the actual things that they've done, so obviously one of the ones I mentioned was just getting, all those tests passing the existing stuff all green. But what's been really interesting is we've brought another level of, I guess, approaches or theories when it comes to testing, right? So one of the ones that has paid off huge dividends has been property-based testing that got introduced into the project, right? So that's using libraries like Quick Theories, I think is kind of one of the popular ones out there. And really what it is it's around checking that certain properties hold true for a range of all possible inputs, right? So it's kind of a little bit like fuzz testing or fuzzing an interface, but it's actually defining the ranges in which we operate there, the bounds that we're going to explicitly check. I'm leveraging libraries that can check, that understands those edge cases. So, when we're in bounds, out of bounds, on the bounds, all that kind of thing. But it is all like randomly generated as well. But there's some great support by the libraries to make that replayable as well. So then when we catch a bug through a random replay, we can grab that seed, recreate that data, jump in there, go have a look at that, right? So property-based testing has been absolutely huge. I know that there are plans for things further down the line, like simulating certain things. We've had a number of people who previously worked on databases like React and Foundation DB come across, and those two databases had a really great approach to testing and simulation and that kind of thing. So we're starting to see all the great lessons that those communities have learned being applied to Apache Cassandra, right? And so we're seeing a huge improvement in the number of bugs that that we actually catch, right? Like, it's really good when you take a new testing approach and you're like, oh, well, look at all these bugs we've uncovered, which has been really, really cool. I think we're also starting to see, as we make some of these components within Apache Cassandra more pluggable, it's going to make those more testable as well, right? So exposing some of those interfaces. That's some of the, exciting work around the testing side of things. I do certainly apologize to the community members if I've missed anyone's pet ticket. I owe you a mea culpa, and I'll plug it in the next podcast.
Another interesting aspect of the ecosystem around Cassandra is there are projects such as ScyllaDB that are leveraging the popularity of the interface of Cassandra and its promise of being able to be scalable and fault tolerant, but completely re-implementing it from the ground up to cut down on the overall hardware requirements and be able to ostensibly provide higher performance guarantees. And I'm wondering if you can talk to some of the ongoing utility or benefits of projects such as ScyllaDB or anything else that's operating in the space, particularly in light of Cassandra 4 coming out, and just what you see as the overall potential in the ecosystem for supporting multiple implementations of the Cassandra interface versus the specifically Cassandra project.
Yeah, so I'm always in a dual mind about this, right? I think it's really, really exciting to see projects take some of those Cassandra concepts and to adopt, CQL and to adopt, the Cassandra native protocol, right? And I think it speaks to the volume of, how excited people are about Cassandra, what a useful spec it is, a well-defined spec as well, because people can go and implement it easily. And it's really, really great to see a broader ecosystem kind of evolve around that, right? I think it's been really fascinating to follow, some of the ideas that people at Scylla have taken and applied to that. But it's also been really interesting to see how, other people have done that as well. I know there's other things like Yugabyte. You look at some of those cloud native services, so like Amazon Keyspaces. I think Azure Cosmo DB has a Cassandra compatible API. Like, there's all these things out there. And they all do it to some varying degree of success, or, kind of works, or a lot of them work really well. Some don't work quite as well. But it's a great stirring pot or a melting pot of ideas, right, that we get to see. And I really enjoy that aspect of it. I think where I kind of flip back on that is, I always get a little bit disappointed, and I would have really loved to have seen some of those ideas explored within the Apache Cassandra community. One of the really great things about it being an Apache project is the Apache Software Foundation owns the IP, right? Owns the trademark. It is a, non-profit IP holding vehicle, right? So it kind of creates this wonderful space where different competing companies can come together and work on some of this stuff, right? And so, it's not like, people have to go work on a competitor's product or something. This is a shared common good, right? This is true open source software. It lives at a foundation. It's really, really wonderful. And I want to caveat that you can have really great open source software even if it doesn't live in a foundation, but it makes it easier for commercial players to contribute, right? So I always get a little bit sad that maybe some of these ideas didn't get explored within the Apache Cassandra community. Having said that, Apache Cassandra community is the biggest community of, things that implement CQL, right? It is the original, it is the reference spec, it is the thing that does it. And what you'll start to see is that the successful ideas from these other projects will start to filter into the Apache Cassandra project, right? A great example of this is, one of the things that ScyllaDB does really nicely is it takes a bit of a different internal architecture, right? So it leverages thread per core, which is way better for more modern machines where you potentially have more, hardware threads than you would previously, say 10 years ago, can take better advantage of that, right? There are a number of tickets out there in, the Apache Cassandra Jira about exploring how do we implement thread or move towards an architecture that is more like that, right? Cassandra 4.0, it doesn't get to thread per core. It's still very much the Cedar architecture that Cassandra uses. But on the networking side of things, we've seen a great reduction in, say, the number of thread pools that we use to do network communications, the implementation of the Netty library, a few other bits and pieces, which is actually seeing some really, really great performance improvements, right? So, the great thing about open source software is we can look at, even though they're not necessarily doing these things in the community, we can kind of look around and see, oh, well, hey, they're having great success with that, right? It's kind of that share and share alike of different ideas and concepts, right? So, it is really exciting to kind of see that taken with Apache Cassandra and seeing that kind of happen. So that's my very convoluted answer to that particular question. I'm excited to see what the future holds and where we can learn from things. At an intellectual level, I'm very excited to see how those different other communities go and some of the cool ideas that they implement. I think for most of them that are doing it out in the open, that's a great chance for us to kind of learn from each other.
And then switching gears a bit, talking about Cassandra specifically and some of the ways that it's being used, it is primarily used as a system of record because of the durability guarantees and because of the fact that it is able to be fault tolerant at both the cluster scale and the geographic scale. And I'm wondering if you can talk to some of the additional systems that people will often pair with Cassandra for being able to take advantage of its durability guarantees, some of the overall sort of system architectures that you commonly see Cassandra involved in, and some of the, I guess, interesting elements of what the project has enabled from a data platform and data systems perspective.
Yeah, definitely. So, the things that we commonly see deployed side by side with Cassandra tends to be other, what I'd call data layer or data infrastructure technologies that also tick some of the same boxes that Cassandra does, right? So high durability, great scalability, right? So we also see Apache Kafka get deployed side by side with Cassandra because it is a highly scalable, durable message bus, right? And you see this move towards, microservices, CQRS, and kind of having to do data hydration. Kafka is a great choice for that, right? And we also see things like, either OpenSearch, right, the Elasticsearch fork being deployed side by side with Cassandra to kind of enrich some of that indexing capability. We see, things like Redis or Memcache or other bits and pieces like that as well, to potentially help out with some of that read workload side of things. So that's what we see deployed side by side with Apache Cassandra. There is a huge ecosystem, right, of other things that do get deployed side by side. That's just, I'm just painting a very small picture. There's a much broader landscape out there. And I think it actually, in that element, it goes towards the fact that we live in this land of polyglot persistence, right? So people just essentially choose the right tool for the right job, right? You rarely come to a company out now where they say, oh, we're an Oracle shop, right? Or we're just all on MySQL shop, right? Like, usually you come into a company and there'll be like 2 or 3 main databases or, that are the source of record, right? Store of record. And with that in mind, you do see different patterns kind of emerge. In terms of what are the challenges, I think that kind of crop up with, first of all, one, this shift to microservices, and you see Cassandra get deployed on there. I don't think Cassandra is like, what I would call a core component of a microservices approach. It's just part of, some of the tools that a service will choose if they've got a certain set of requirements around availability, right? But when it comes to microservices, when it comes to, some of that scale up stuff and polyglot persistence, you end up in this situation where, in order for businesses to understand what's going on, from a, business level set of metrics, they need to get data from all these different systems, into one place, right? So that, business analysts, leadership, product managers can kind of see what's going on, right? And so we see a lot of people thinking about how do we get this data from our transactional data stores into, our data warehouse, into our analytics capability, right? So I think that's one of the challenges that we see a lot of people grappling with There's some really great projects out there that help with that, and we work very closely with some of these. The project Debezium is amazing. I think it does far more heavy lifting, and it should be a far more popular project than I think a lot of people, kind of understand about it. Debezium it essentially allows you to, grab that wonderful CDC data from a lot of databases and dump it into a Kafka stream, right? Sounds very simple, but it's so important, right, to being able to get your transactional data, kind of core usage data, all that fun stuff into, your data warehouse or wherever it needs to go. So, doing those integrations, making sure that you kind of know what's going on and that things aren't getting too compartmentalized or siloed is super important. And I think that's kind of the next set of challenges that a lot of companies are going to face given their current data infrastructure.
Schema changes, missing data, and volume anomalies caused by your data sources can happen without any advanced notice if you lack visibility into your data in motion. That leaves data ops reactive to data quality issues and can make your consumers lose confidence in your data. By connecting to your pipeline orchestrator like Apache Airflow and centralizing your end-to-end metadata, DataBand lets you identify data quality issues and their root causes from a single dashboard. With DataBand, you'll know whether the data moving from your sources to your warehouse will be available, accurate, and usable when it arrives. Go to dataengineeringpodcast.com/databand today to sign up for a free 30-day trial and take control of your data quality. As a brief aside, I'm wondering if you could talk a little bit about some of the data modeling characteristics of the Cassandra database and some of the ways that you need to think about structuring the data and working with the data that it stores, and the juxtaposition of how somebody who's familiar with a relational database might need to transform their thinking to be able to take full advantage of how Cassandra is able to store and partition and distribute data.
Under the hood, Cassandra leverages what's called the Google Big Tables data model and storage engine model. And to be fair, it has changed a little bit from like the original papers and the way that it kind of works. But in terms of what a developer will see when they come and start working with Cassandra, the query language and the data definition language is very, very similar to SQL, right? And in fact, deliberately so, right? To make it very easy for developers to come from one environment to the other. Unfortunately, that also, once you become experienced with it, becomes a little bit maddening because you're like, oh, I can do this with SQL, but I can't do this with CQL, even though the syntax is very, very similar. But developers will find themselves in a situation where, they're working with very familiar objects, tables, insert statements, update statements, select statements. But in terms of the actual data model itself, Cassandra kind of has a number of things that you need to think about, right? So first of all, it has a concept of a primary key, very similar to SQL land, and that is like the unique identifier to look up a given set of columns. Within the primary key for Cassandra, you've got two components. One is called a partition key, and this is just a set of columns that determine which node your data lives on, right? So it's the thing that gets hashed and gets assigned, within the cluster space. Cassandra provides a certain number of guarantees around when you do certain operations within a partition. It can provide certain guarantees around that. The next part of the primary key is called a clustering key. The clustering key is essentially the way that Cassandra will lay out that data on disk, right? So let's say for your clustering key, you set it as a timestamp, right? So all those timestamps will get laid out on disk in order. This is really great because then Cassandra allows you to do what's called a range slice over that particular column, right? So if you know your partition key and then you know a range of your clustering columns, you can do a query across those. And then you've just got regular columns, right? So that's kind of a very high level of the Cassandra data model. The best way that I like to think about it is Cassandra is essentially a map of sorted maps, right? And it's kind of had that projected onto more of a table-like representation, right? So that's the Cassandra data model at kind of its core. A lot of things build on top of that. Cassandra brings great features as well to the table. It brings things like counters, right, to do distributed counting of things. It is what I would call, it's not like exactly accurate, but it's really good for counting things like the number of likes on a tweet, for example. It brings the concept of lightweight transactions. So using Paxos under the hood, you can provide some safety around when you do certain updates, right? So you can say, hey, update this row if it doesn't exist or if it has a prior value, and it will do that all nice and safely. So there are some nice things on top of that. You can also have different, it's got great support for different rich data types like, JSON and sets and other maps and other bits and pieces there. So usually, like, when you come to it as a developer, like, all this is going to be very familiar to you. It's going to be easy to start working with it. It is definitely a little bit more of a restricted environment than, say, an SQL environment. You don't have joins or foreign keys or anything like that. And we do that to ensure that we can scale out really nicely. But for anyone that's kind of run an SQL system at scale and have had to, maintain a really, really big table, you often end up having to drop those foreign key constraints anyway for performance reasons, right? So by the time you get to Cassandra, you've already kind of given up a lot of those anyway. So that's kind of Apache Cassandra in a high level, the data model. If you're kind of interested, I'd definitely, there's heaps of great books and resources out there. There's 2-day training courses and all sorts of things that you can kind of jump in that will make you really understand this stuff. But usually, if you're coming from an SQL world, you'll be able to find some way of doing things. The one thing I think I kind of missed in that description is you kind of certainly need to denormalize your data when you are coming from that SQL world, right? So you will find yourself storing data in multiple places, multiple tables twice. Cassandra is definitely one of those things where you need to architect the way that the data is laid out based on how you're going to read it back from the database, right? So that might mean a bit of a double up of data. But it's, storage is cheap nowadays, right? So, it kind of makes sense to do that.
And then switching to the operations aspect of running Cassandra, one of the things that is notable about the way it was architected and designed, when it was first created, 15 years ago almost maybe, is that it is kind of prescient in terms of the ways that it's able to manage executing in cloud environments, and particularly with the so-called cloud native design patterns that are growing and being established right now, particularly with things like Kubernetes. And it seems that Cassandra is very well suited to be able to slot into a lot of those ways of thinking about just deploying and managing infrastructure. And I'm wondering if you can just talk to some of the opportunities that you see for the Cassandra project, particularly as it's, coming in with this new version and as these cloud native patterns are being established and gaining more prominence.
It's kind of interesting, Cassandra kind of like it was built and developed in a world where, cloud wasn't around, right? Or very, very nascent. I'm not going to look too closely at those dates, right? But I think what lends Cassandra, it is one of the original cloud native databases, is the fact that it came out of the box with a great understanding of where it's deployed, right? So it understands what fault domain it's deployed in. It understands what data center, what region, what rack it's deployed in, right? And all those concepts map really, really well to the cloud, right? So you can think about your rack as your availability zone, right? Or you could think about, how, say, Kubernetes with its annotations labels also understands where a given rack is, what a given availability zone is. All those concepts just map really, really nicely together. So the fact that Cassandra has this understanding of network locality, value domains as a first-class citizen, it kind of, it very easily steps into that role as a cloud-native database, right? There's also some really interesting things happening within the project as well. For example, making the storage engine more pluggable. We're going to see that really take off as well with another great concept that kind of came out of the cloud-native world, which is the ability to separate storage from compute and memory, right? And we're going to start to see more and more of Cassandra being able to support different patterns, different storage classes, but also, scale up, pods and stuff, or pods or instances of VMs or whatever you want to kind of call it, independent of, different storage mediums, right? Which is going to be really, really, really cool. In the community as well, there's been a ton of efforts gone into making it easier to run Cassandra on, some of those more cloud native platforms. You've obviously had, service providers like Instaclustr doing it for years in the cloud, but you're also starting to see other projects around, say, Kubernetes form, right? So a number of different operators for Apache Cassandra. We've written one. I know DataStax have written one. I know Orange, the big telco in France, have written one. Been a whole bunch of really, really great work around this. And, internally within the community itself, we're also seeing the community starting to standardize on a community-owned Kubernetes operator as well, which is going to be really, really exciting to see. We kind of found ourselves all in this situation where there was like 3 or 4 quite viable production-ready operators, which is not a great user story, right? We all kind of came to it and, went and developed it, by ourselves independently. But we all kind of got together and go like, hey, look, we need a standardized community one, right? That's what makes sense. So there's a great community effort going on. There's a working group or a steering committee kind of meets, I think, every second week or something at the moment, and progresses on that as well around building out a community operator for Kubernetes. So yeah, super exciting stuff kind of happening in that cloud native land for sure.
As somebody who has been aware of and sort of passively tracking Cassandra for a number of years now, it's been notable that there was a lot of popularity and attention paid to it maybe 5 or 6 years ago, particularly with Netflix being a major user of it. And I think that maybe it was Heartbleed that came out when they announced that they were able to rebuild and redeploy their entire Cassandra infrastructure over a matter of a short period of time without having any outages because of the fact that they were running Cassandra. And then maybe in the past 2 or 3 years, I haven't heard a lot about it. It's been sort of fading. And then now with Cassandra 4, I anticipate that we'll be hearing more about it. But in the past, especially 2 to 5 years, at the same time, there have been a lot of new database projects and products that have been coming to market. And I'm wondering if you can talk a little bit about your perspective on Cassandra's role and opportunity within the overall space of data management systems, given the fact that there have been so many new entrants to the market that are targeting high scale, high availability, global scale, and sort of global fault tolerance capabilities.
Yeah, definitely. It's super exciting to see what's happening in some of those communities. You look at things like CockroachDB, Vitess, all those, I guess, what are they calling themselves? New SQL, or I don't know the moniker for them. But it's super exciting to see what's happening in that space, how they're tackling some of those problems. We kind of go back to, I think, Brewer's theorem around, CAP, right? Consistency, availability, and partition tolerance. And each one of those ones take a slightly different approach to how they do their databases, right? So with Apache Cassandra, because it prioritizes by default availability, whereas I think some of these other ones are kind of much more around consistency, I think we're going to see a lot of them probably sitting side by side, to be honest, where there'll be some use cases where something like test is the right fit, 100%, right? And it might sit side by side with Cassandra, where the availability is a higher priority than, say, being able to do some of the things that Vitess can do. I think there'll be users of both that maybe like leave one and go to the other, just as people who have adopted one because they had one use case, but it wasn't a perfect fit, but the other thing might be more of a perfect fit. I think you're going to see some of that cross-pollination or that transition happening for sure. But, I think at the moment, in terms of kind of what Cassandra brings to the table, it's probably, still for a number of use cases, one of the only real open source choices out there, right? But I don't know. I always take a very long-term community view around this kind of stuff, which is, it's really great to see other projects and other databases and other data stores explore different ideas and how they approach those, how they tackle it. And then also just seeing what people's experiences are with them, right? Because, code changes, right? Projects change. We can add new features. We can remove old features, right? I think if we see something that's a great fit for the Cassandra community and people like talking about it and that kind of thing, it's like, hey, we can always look at, is this something that we want to adopt, right? We see someone has had a great experience with this, maybe this could really also help Cassandra out. We've seen that go the other way. We've seen lots of these projects learn those lessons from Cassandra, right, as one of the earlier big scale-out databases. So I don't know, I'm a big Cassandra fan, but I always just love seeing what other projects do and how they approach it. And, it's really fascinating to see the problems they tackle.
Do you have any sort of predictions or perspectives on the near to medium term future of Cassandra and some of the opportunities that you predict given the new release and the focus on stability and reliability that the past few years have invested in?
So I think we're going to see performance only get better, right? I think when it comes to, support for some of the new JVMs, we've seen some great testing and stuff around that. We're going to see more of that pluggability kind of come in. I think people are going to pay more attention to some of the stories that are being told about Cassandra. It's funny you mentioned previously that like there was a bit of a lull and, with Netflix talking about how easy they replaced a whole bunch of stuff. All those companies that were telling great stories about Apache Cassandra, they still use Apache Cassandra, right? And I've done this just a very ad hoc exercise where I've talked to different community members who, work at various big companies and their deployments and that kind of thing. And, I would happily or easily, put a bet down that, in terms of the vast majority of the online population of the world, right, on a daily or weekly basis, they would interact with a service that's backed by Apache Cassandra, right? You think about it's used at Netflix, it's used at Apple, it's used at Spotify, it's used at some of the biggest banking and financial institutions powering their retail and transactional services, right? So, even just holding that like maybe 10 companies in your head and the use cases that Cassandra powers there, right? Like that's touching and interacting with already more than 1 billion or a couple of billion people globally, right? So, I think the premature death of Cassandra has been reported quite often, but, it's always a little bit premature, just to butcher that quote for a second there. But I think with 4.0, I think people are going to, hey, we're still powering along here. And I think it'll just be a nice chance to tell some of those stories again and tell some new ones, right? There's been some great use cases kind of popping up over that period of time. And yeah, I'm just excited to see, people maybe coming to the community after hearing about the 4.0 release and starting to participate or think about deploying at Cassandra.
It's already crested the hype cycle and has gone to being boring technology in the best sense of the term.
That's it. And I mean, look, don't get me wrong. Cassandra rode that NoSQL hype wave, 6 or 7 years ago, right? And, we're now in just, hey, it's boring technology, man, right? Like this is the reliable tool you pull out of your tool bag and, off you go. It's a good place to be for a database, let's be honest.
Absolutely. And so in terms of some of the ways that you've seen Cassandra used both in the community and in systems that are powered by your managed service at Instaclustr, what are some of the most interesting or innovative or unexpected applications of Cassandra that you've seen?
That's a really good one. So for a fact, I can't name who it is, but I do know that Apache Cassandra powers the source of record for a major banking financial institution when it comes to transactions. And people are like, well, that's not like a weird use case. Hear me out for a second. A lot of people always go, you can't use weekly consistent databases for transactions, for banking transactions, for financial records, right? You always, and this is the stereotypical example of why SQL transactions are great, or ACID-based compliant transactions are great. It's because what happens? You get these two different transactions, you have negative balance and blah, 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 blah. Well, Cassandra is an AP database, right? Features availability, prioritizes availability and partition tolerance over this stuff. It can power that transaction workload. And the bank's having a really, really great time about it, right? The other thing I love to educate people on is actually also banks by default are eventually consistent, right? That's why we have things like overdraft fees. It's because at one point the bank didn't know how much money was coming out of your account, right? And so they couldn't stop certain things coming out of your account. So that's kind of my favorite example about here's a really, really boring use case that people just don't expect Cassandra to be used in, right? There's some also really cool stuff I know it's being used for, storing feature sets when it comes to machine learning. I know it's being, used for, powering some great recommendation engines. I know it's being used to power, kind of emergency assistance services and other bits and pieces. Again, because Cassandra, it's done that hype cycle. It's kind of in that stable thing. It's every use case you can imagine. I'm sure Cassandra has done it, right? So, that is kind of the exciting thing about working with Apache Cassandra. It's kind of it has touched most use cases. But yeah, they're kind of just my main ones. But I do love the fact that it powers financial transactions, right? How cool is that?
And then in terms of your experience of building Instaclustr and being engaged with the Cassandra community and working on the project, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I think this might be true for all open source projects, right? Which is, It's very much around bringing the community on a journey, right? So it's one thing to be like, hey, I've got this awesome feature, or we should patch it this way, or we should do something like that, right? But you got to bring people on the journey. You got to build that consensus. So that's really, I think, from my perspective, and that's where I'm at the moment. I know you're probably looking for an interesting, weird, technical answer to this particular question, but, I think, the challenging lessons I've had to learn is, it's really about bringing the community on a journey, right? And communicating with other people in the community and interacting with them and just working together, having your disagreements, but being able to move on and kind of pull together in the same direction is really, really huge. I'm really glad it's a lesson that I learned, right? It's a wonderful lesson that anyone should learn. But I think the Cassandra community, it was a great place to do that as well. Like it's a really nice, welcoming community as well. So yeah, definitely.
For people who are interested in Cassandra and excited about the reliability and durability guarantees that they're able to get out of it, what are some of the cases where it might be the wrong choice and they're better served by using some other scale-out system or just going with Postgres or MySQL as the reliable workhorse?
So I think there's kind of two sides to that, right? If you're building a new service, a new project, new startup, whatever that might be, pick the data store that you know that allows you to get started the quickest, the easiest, and start learning about how people use your service or product or whatever it is, right? Because sometimes you can fall into this trap of being like, oh, it's going to be so big, so we've got to choose Cassandra because, we've got to scale out easily, blah, blah, blah. The answer is actually no. Choose the thing that gets you up and going the quickest and lets you learn lessons about the problem domain that you're working in the quickest, because you're going to rewrite your data layer 3 or 4 times before you even get to the point where Cassandra starts to be a viable option from a scale perspective, right? So learn those lessons along the way. Also, it can be quite, I think, useful to learn about the challenges of scaling out certain other systems before you get to Cassandra, because when you get to Cassandra, you'll be like, why are there these restrictions? Or why can't I do things like joins? Or why can't I do this? But if you face those challenges in other systems, you'll be like, oh, I understand now why, because they're also slow in these systems when I try and do it at scale, right? So yeah, pick the thing. Don't pick Cassandra if you don't know it and you want to move quickly. Of course, there's definitely greenfield applications out there, particularly, if it's a new service from a really large company where it's like, hey, we know we're going to have, 5 million people from day one, right? Hey, well, you've already kind of, that choice gets made for you and you might need to kind of pick up Cassandra with that. So that's the one side of things where I wouldn't use Apache Cassandra. The other side of it is if I'm just storing data for a pure analytics perspective, right? I would not choose Apache Cassandra as my backing data store for a data warehouse. Definitely not. It's not to say that you can't do analytics in Apache Cassandra. There's some great Spark plugins and connectors and other bits and pieces, but you're just not going to get the same performance as you would with, say more of a column-oriented data store, right? Or a columnar storage format, right? Like something like Parquet and, throw all those files on S3 or whatever it might be. I'd definitely steer clear of Apache Cassandra for a pure data warehouse or data analytics perspective. We do see some like custom built data warehouse systems where they use Cassandra as either an index or a kind of a record keeping piece, but the data itself does not live in Apache Cassandra. That's for sure.
We've already talked a little bit about this, but what are some of the things that you see as being in store for the near to medium term future of the Cassandra project?
Yeah, so I think we're going to see some exciting features around, the pluggable storage engine. We're also going to see better use of things like virtual tables, right? That was a new feature that got introduced in 4.0. Virtual tables, you're probably familiar with them from like MySQL and other bits and places where you can query statistics about the database itself in those virtual tables. We're going to see much better use of that in Apache Cassandra. We're going to see some improvements to the way that we do Paxos. We're going to see some improvements to the way that we do schema and gossip management, which is going to make operations around large clusters and changing schemas in large clusters way, way, way easier. So we're going to see some great work around that. We shall see some stabilization of what's called transient replication. And that's a really cool technology. It's in there at the moment, but it's currently experimental, and we're going to see some better improvements around that. Transient replication is a really, really cool way of increasing the durability without really increasing the cost associated with needing to say, if you want to go from a replication factor of say, 3 to 5, it allows you to get that replication of 5 without needing to run quite as many nodes, right? So it's a great kind of durability booster. Yeah, there's going to be heaps coming down the line, right? I know that there's a ton of developers that during the 4.0 feature freeze are like, I just want to get my ticket in and get this kind of committed. But 4.1 is going to look really, really cool from that perspective.
Are there any other aspects of the Cassandra project or the ways that it's being used or the recent release that we didn't discuss yet that you'd like to cover before we close out the show?
I think this has been a really wonderful tour. We've touched on everything from, Cassandra being a great fit for cloud native applications, some of the journey and the history and where it's a great use or a great choice. I think really I'd invite all your listeners who have previously used Cassandra or have always kind of been interested or just hearing about it for the first time to actually go to cassandra.apache.org and download 4.0 and give it a go, right? I think you'll be pleasantly surprised. There's a whole bunch of resources out there to help you get started on the site now. We've also undergone a bit of a site refresh for the Cassandra project as well. So definitely go download 4.0, give it a try. And, if you're already running Cassandra, think about doing that upgrade because there's some really good things in store for 4.0.
And I guess briefly talking to the upgrade aspect, are there any sort of notable upgrade sort of gotchas that people need to be aware of before they click go and go from 3.x to 4?
Yeah, definitely. So make sure you are on the most recent minor patch version of whichever branch you're on. So Cassandra 4.0 supports upgrades from 3.11 and 3.0. And make sure you're on the most recent minor versions of those. If you are running large clusters, and by large clusters, I mean 400, 500 nodes, wait until 4.0.1. There is a patch that makes those upgrades for those very large clusters a little nicer, a little easier, particularly when it comes to, if a node goes down during that upgrade process. Honestly, that's it, right? Like just, get your current cluster up to the right version. Double check that changes.txt file, which will have a whole bunch of information about if you do things certain ways, what to pay attention to, how to change your config file to meet that new one. But yeah, give it a go. It should be a pretty painless journey.
Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Yeah, definitely. So I think this is one of my pet kind of topics to talk about is, we as software engineers, we spend a lot of time, working on, doing things with data and where data lives that aren't necessarily always related to the core application functionality, right? And so what I mean by that is, sometimes we've got to do things like, we've got to cache records because it's slower getting it from one database to the other, right? Or we've got to do something where it's like, hey, we might be on a MySQL database and we've got one big customer. We've got to shard that out to another MySQL database, right? Or we might suddenly have a requirement to start encrypting records, right? For, either PCI or privacy or whatever it might be, right? These are all things that we have to do as developers where it doesn't change the behavior of our application. Our application doesn't need to know about it, as long as we can run that same query and it comes back the right answer. We really don't need to, have that logic built into our application, right? So I think one of the challenges that we have when it comes to to data management is to actually, stop making developers do some of that schlep or that grunt work and start working on tools and capabilities that make it easier where we can do that at either the database layer or at the driver layer or whatever that might be, that makes some of those things a lot easier where the developer really shouldn't actually care as long as they're getting that query back in the right way, right? So we've got some things that we're working on around that space, but it'd be great to see other people kind of working on that space around that interaction between the application and the database about all these things that we have to do that really the application shouldn't care about or doesn't need to care about because, hey, the query is still the same, right? So yeah, that would be my view on what's the biggest gap when it comes to tooling or technology for data management.
Well, thank you very much for taking the time today to join me and share the work that you've been doing with Cassandra and helping to support the community and some of the news that's been coming out of that project lately. So appreciate all of the time and energy you've put into that, and I hope you enjoy the rest of your day.
Thanks so much, Tobias.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts@dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.